Configuring wireless networks. By the time you're done here, you will understand how to configure wireless networks and basic security through a controller-based design. When you set up a wireless access point, one of the first configuration settings that you'll choose is an SSID. That's a security set identifier, and essentially that's the name of the wireless network that's broadcast into the air for all the devices to join. Most of the home-grade wireless access points will only support one SSID being broadcast at a time. It's kind of its global setting, whereas business-grade wireless access points allow multiple SSIDs to be broadcast. Now, the number of SSIDs you can have is really dependent on the equipment that you're using. For example, we're implementing Ubiquiti wireless access points throughout this series, and they have a limit of 4 SSIDs, at least on the ones we're implementing now, although some new wireless access points were just released that supports up to 8 SSIDs. Now, the first question is, why do you need multiple SSIDs? Well, in a business environment, you have diverse networks. You might have a guest network where people get on and just surf the wireless, but they're restricted from accessing anything internal. Whereas internally, you might have a network for your employees that can access just about everything from a file share perspective and printers and basic internet access. But then maybe you have a surveillance SSID where if you join that, you have access to the different security cameras installed at your company. You can see all of my examples are orbiting around security levels, but you also have different treatment groups. For example, maybe on the guest network, you limit the bandwidth per client to 1 megabit per second. That way, if somebody brings in a laptop from home that's running BitTorrent and doing file sharing, it's not going to consume all of your internet bandwidth. One thing I've got to warn you is that multiple SSIDs do give you an excellent level of flexibility. The problem is they really impact your performance. If you head on over to revolutionwifi.net, which has a ton of great material, by the way, you can see that he created a table. This is actually in Microsoft Excel because you can use it to generate how much overhead is affecting your network, where he says, based on the number of wireless access points on a specific channel. So let's say you've got 2 WAPs sharing a channel. They're both on channel 1, 6, or 11 in the 2.4 gigahertz space. And you have 2 SSIDs running on each of them. That immediately consumes 12.9% of your frequency spectrum just for overhead. So you can take a look. Those wireless access points that just came out that support 8 SSIDs, well, that's great. But if you've got one wireless access point doing 8 SSIDs, 25% of your overall radio frequency immediately sliced off just for the overhead of running those SSIDs. If 2 wireless access points shared the same channel with that many, 50% gone. That's insane. So you really have to start thinking about the SSIDs you use and be very intentional on rolling them out. Now, what about wireless security for those SSIDs? Well, you always have the option of leaving them wide open. And I see that done a lot for the guest network because a lot of organizations want visitors to be able to walk in and just get it basic internet access while they're sitting there in the lobby. And that is nice because you don't have to post a sign or they don't have to bother the receptionist. But one of the challenges you may have with that goes back to the very properties of wireless. The further away you get from that wireless access point, the worse your performance is. And if you get a device that attaches really far away, and starts heavily using that wireless access, it can really impact the performance for the people that are closer in. Now, if you've got a guest network that's wide open, you may have somebody in a neighboring building or just sitting out in the parking lot that jumps on there and starts streaming a movie. And maybe they're sitting there for a long time. I've been there sitting in a parking lot. What do I do now? You don't want to tether your cell phone and eat up all your data plan. So you look for a wide open wireless network and start using it. Well, that's going to impact the performance of all the devices that use that wireless access point, not just the guests. It's everybody. So because of that, you might jump into at least a pre-shared key, or what most people call WPA2 PSK when they're talking about wireless access point configuration. It's just where you type in a key, let's just say 1, 2, 3, 4, 5, 6, 7, 8, that everybody that connects to that wireless access point has to type in to join the SSID. The challenge with pre-shared keys, especially as you get into a large environment, is that good security standards mandates that you change those things on a regular basis. Employees come and go. You may have one of those shady guys that want to get back on the network after he's let go of from the organization. And when you rotate that key, you have to change it for all the devices, which means a ton of communication and a ton of troubleshooting for the IT department. And that's why a lot of IT departments choose to go with 802.1x, EAP, or WPA2 Enterprise. Those are all the same names for the same thing. They're just looking at it from different perspectives. All it means is that instead of the wireless access point doing the authentication with a pre-shared key, it relies on a server that's typically connected with the Radius protocol. And that server is often an LDAP database. Good old lightweight directory access protocol. That's like Active Directory in Windows, or OpenRadius in the Linux world, or Novell NetWare, if you have one of those. Just had to throw that one out there. You create all your user accounts on here or your authentication methods on here. The beauty of 802.1x or EAP is it's extensible. You can have people doing retinal scans to get on the wireless network. Their smartphone pokes their finger and does a blood test. Once you move the authentication off of the wireless access point, it's now extensible to whatever you want to do on the server. All the wireless access point has to know is, does this person get online? It passes whatever credentials, from a password to domain membership to a blood test to retinal scans, whatever, over to the server, and whatever server software you're running that authenticates that says, yes, their eyeball is good. And the wireless access point lets them online. So now I'm going to pick up right where the last video left off. We went out to the church and we installed the 5 wireless access points. They're all checking in. Well, at least 4 of them are. But none of them have been configured for a wireless network. So the first thing I'm going to do is configure wireless networks so that we can get connectivity across the site. Then we'll locate each one of the wireless access points and label them, which is going to be huge for our configuration and troubleshooting in the future. All right, now that we've got at least 4 WAPs in there, we're still bringing the 5th one up. I'm going to go in and configure the wireless network. So I'm going to go over to the settings right here. You can see this is the site that we're at, and we've got that all configured correctly, and I'm going to drop down to the wireless networks. Now, as of right now, no wireless networks have been configured. Now, notice the wireless LAN group up here is currently set to default. I'm going to click on plus to add a group, and I'm going to name it US 2021, which is our site code for this location. Click on save, and we've now got a new group that's ready to be configured. I'll click on create new wireless network, and right there is the name that I'm going to type in. Now, I worked with the church beforehand to figure out all the network names that they wanted. I've got that in an email right here. So I'm going to put in Evident Life Internal. That's the first SSID. Paste. We'll make that security WPA personal. And the security key is all for him, exclamation point. Copy. Paste. Hit save, and now I've got my first wireless network listed. I'm going to repeat that process for all the wireless networks that they have. And we're done. Evident Life and Evident Life Internal. Now, I got a little fancy here because they also wanted one for the audio-visual equipment, meaning they wanted the 2 wireless access points in the sanctuary to have a separate wireless network just for their AV equipment. That allows only certain devices to join and manage all the sound equipment that's there. So, the last piece that we need to do is get into the devices themselves and assign them to those wireless access groups. Now, we haven't named them yet, so we just see them by MAC addresses. We'll have to figure out where they are. But for the time being, to bring up the wireless network, I'm going to click on each wireless access point, hit the configuration here over on the right-hand side, wireless LANs, and I'm going to assign both the 2 gigahertz and 5 gigahertz radios to the wireless LAN group US 2021. Once I figure out which wireless access points are in the sanctuary and rename them so they're not just MAC addresses, I'll assign those specifically to the AV group. Hit Q changes, and I'm going to do this for every wireless access point. There we go. 4 devices with pending changes. Hit the drop down and apply to all. At this point, once these wireless access points re-provision, we should now have working wireless for this location. And sure enough it is. All the wireless networks are back online, but take a look at this. We've saturated the airwaves with all these different wireless networks. And if I look at 5 gigahertz, you can see that all of them have piled up there on channel 36, which is not good. That's because we left all the wireless networks to auto-detect what channel to use. And you always got to remember, you auto not use anything that says auto in it. So we want to go in and manually change those channels so that we get a clean signal from each WAP. Now, before we can go change the channels, we've got to figure out where these WAPs are, because right now they're all checked into the controller with their MAC address. So before we can configure the channels, we've got to label where these WAPs are. Figuring out which WAP is what is one of the most fun things that you can do, because first off, you get to sit in these nice big plush chairs, but also as I'm looking at that WAP on the ceiling and looking at my controller, I notice all of them have a locate button next to it. When I click on locate, it's going to start blinking the light on the WAP that I've chose to locate. And I look up right now and that one is blinking. So it just so happens that this wonderful place I sat first is that WAP. So I'm going to click on that. shoot on over to the General tab, and I'm going to give it the alias. Now, the way that I name them is the site name, US 2021-AP01, and I just start numbering them. If you want, you can start putting sticky tape on each one, so you can look up and physically identify that's AP01 without having to blink it in the future. I'm not going to do that right now. And I'm going to put dash prayer room, which is the location of this WAP. Click on save. Now you can see in our controller, we have our first one identified. So I'm going to go around to each one, blinking them, and let me turn off this blinking right now, blinking them and identifying their location in the controller. All right, there we go. They're all labeled at this point. Now we want to come back to our original floor plan, which showed individual assignments of the channels, both 2.4, that's the 1, 11, 6, 1, you can see going around here, and the 5 gigahertz space, 52, 44, 64, etc. So now we want to come in and statically assign those channels to each one of these WAPs. I'll hit the Sanctuary North because that's where I'm sitting right now, and that one should be 11 and 44. Come over to the configuration, scroll down to the radios. And instead of keeping it on auto, I'm going to say the channel will be for 2.4, 11, because you can see right there, radio 2G. And then radio 5G, I'm going to change to 44. Cue those changes and move on to the next. Prayer room is going to be 6 and 64. Now you might remember some of these are going to be the DFS frequencies, which is shared with weather radio and some other radio signals that are out there. So if there is a conflict, our wireless access point will shut itself down on DFS, but for the most part, you're going to be safe. I rarely have seen DFS come in and shut down a WAP signal. Sanctuary South, 1 and 52. And Fellowship Hall, 1 and 48. 4 queued changes and apply. Every time you do this, it does cause the wireless access points to go down briefly and back up. So make sure you let those clients know that they're going to lose wireless access for a limited time. Looking back at my Wi-Fi analyzer, there's no winning on the 2.4 gigahertz space. It's just going to always stay oversaturated because there's only 3 real channels that you have. And it looks like even in this complex they're in, there's all kinds of people just chewing up this space in channel 8, on channel 4. 5 gigahertz, we're looking much better. We've started to spread it all off channel 44 into some of these other channels. All right, there we go. We've got our channels reassigned. I'm going to add a column in here for the radio 5G just so we can see those channels as well. There we go. Now, it might cause some alarm when you see that there's 2 WAPs on the same 5 gigahertz channel, but the thing is if you look, this is the Sanctuary North, and this is completely across the building at the Fellowship Hall. That's totally fine because with 5 gigahertz, the walls are going to absorb it, and you're not going to get any interference from there. I'm also looking at that channel utilization. Compared to what it was before, I don't know if you remember it, but there was a lot of orange on there, which was interference coming in. That is so much better. Our clients are nice and evenly distributed across a lot of these WAPs. This is looking good. Well, I told you at the beginning of this nugget that you will understand how to configure wireless networks and basic security through a controller-based design. And now you can. You know the difference between having a single and multiple wireless networks. You get a lot more flexibility with the multiple wireless networks, but a lot more overhead as well. We also talked about the different kinds of security, pre-shared key-based and EAP-based SSIDs. Now in this nugget, we only configured pre-shared key-based, which is all this small location really needs. But as you get larger, you'll start looking at moving into the EAP-based SSIDs, which rely on a radius server most often to authenticate devices or users before granting them wireless access. Well, I hope this has been informative for you, and I'd like to thank you for viewing.